Okay, so this is example 39 then. So this is a proof really. It's a proof of this dot product here. And we've got to prove that this is A1, B1 plus A2, B2 plus A3, B3. Okay? So basically what we're doing is, what they've done is they've rewritten as A as equal to A1I plus J plus A3K, and B is equal to B1I plus B2J plus B3K. And then to multiply them, A dot B, they've just used the distributive property. So they've multiplied A1I by B1I, B2J, B3K, A2J by B1I, B2J, B3K. As you normally would if you were multiplying matrices, actually. And that has left us with this middle bit here, okay, where you've got all these terms. So the third equals down. Now, what you've got to remember here is now you've got things like A1I times B1I, okay? Now you've got to remember that I is equal to JJ is equal to K dot K, which is equal to 1, okay? Whereas I dot J, or any combination, JK or KI, is going to equal 0 because cos of 90 is equal to 0. That's why. So therefore, if you look at the terms in the middle here, so you've got A dot B. Now you've got A1I times B1I, and you're going to keep that. Sorry, that's not very good. Hang on, let me go back. B1I, you're going to keep that because I dot I is equal to 1, okay? However, the next term, you've got ij, and ij is equal to 0. So is ik, that is equal to 0. Then you've got ji, which is equal to 0. But then you've got jj, and jj is equal to, j dot j is equal to 1. So you've got a2j times b2j. You're going to keep that one. Then you've got jk 0, ki 0, kj 0, but then you've got kk. So you've got a3k, b3k. Okay, so the dot product is just these three terms. So it's just a1 b1 plus a2 b2 plus a3 b3. Okay. So say if you had two vectors, say you had let me put a different color. A is equal to 3 minus 2, 6. And B is equal to minus 4, 9, 1. Okay? What this is saying, this formula here, A1, B1, A2, B2, 1, A dot B is therefore equal to 3 times minus 4 plus minus 2 times 9 plus 6 times 1. So A dot B is minus 12 minus 18 plus 6. So that is going to be minus 30 plus 6, which is minus 24. Okay? Now you also know that A dot B over the modulus of A times the modulus of B, or the magnitude. So if you want now, you've got A dot B, so now you want the modulus of A, or the magnitude of A, is going to be the square root of 9 plus 4 plus 36, which is 7. And the magnitude of B is going to be the square root of 16 plus 81 plus 1. So that's 82, 88, 98. So that's the square root of 98, which I think is 7 root 2 actually. 49 times 2, yep, 7 root 2. So if that is equal to the cosine of theta, therefore the cosine of theta is equal to our minus 24 over the mod of A, which is 7, times the mod of B, which is 7 root 2. And obviously we're going to use our calculator to find that. I'm just going to do that very quickly. And I make that to be 110 degrees to the nearest degree. Okay, which makes sense because in this quadrant the cosine is negative. So that's how you use the dot product.